So now I wanted to find what pi would be in maximum geometry. And so I started with my formula for pi for a circle in Euclidean, which is 2 pi r is the circumference. And so I looked at this first segment to find just the distance of this, and I found that it was 4 because it's 4 units away from, or the x-coordinates are 4 units away. The y-coordinates are 0, but we just look at the larger one, so I know this is 4. And then similarly, I continued on and I found that all these other distances were 4 around. There are 8 of them, so I concluded that my distance would be 32 units around. Now, so I used the same circumference formula, which was 2 pi r, and my radius I knew was 4 because I'm using the same circle that I did before. So I knew that it was now 2 pi times 4. And so by just doing a little algebra, dividing by my 32 by 4 and then by 2, I got that my pi was 4, which is actually the same as it is in EAS geometry. Alright, now I'm going to look at doing translations using maximum geometry. So I start with these 3 points, 0.00, 0.40, and 0.44. And I decided I was going to move each of them 2 units down, so 2 units in the y direction. And so I just cloned this, and now I have, this is what it would look like moving just straight 2 units down. So then I found what the new points would be. So that's 0.42, 0.0, negative 2, and 0.4, negative 2. As you can see, each of these just moves. The y distance in each of these is just different by 2 units. And so in the beginning, the distance between my any 2 points is 4. And as I continue with my new points, the distance is still 4. So the distance between 4 and 4 is 0. The distance between 2 and negative 2 is 4, and we just look at the larger one, so it's 4. Same with the other ones as well, 4 and 4. And so that's how I know it's an isometry. And I also know if I add or subtract the same number to any number, to any set of numbers, the distance between them is always going to be the same. And because of that, it will always be an isometry.